All right, our newest unit is going to be about functions and graphs in the coordinate plane, but before we do that, we have to go through some different representations that all of these scenarios can take place through. So today's notes are going to be going over those multiple representations and giving you an example of each one of them so that you can see how they all tie together. All right, so the first thing we want to do is identify those four multiple representations, and there are four of them, and you will have to be able to go back and forth between all four of them. Okay, some of them you are very familiar with, and others of them may be a little newer or harder for you to deal with. All right, so the first one that we usually use is words. Some sort of word problem or translating problem is given to you. The next one is going to be equations. From those words, you can write equations. Okay, the next one is going to be tables, which we've done in the previous lesson, where after you now have an equation, you make the table from it. And the last one is going to be a graph. Right? And it is easier to go in the order that I've just given them to you in, but they can give you any one particular form of a representation, and you are going to have to be able to go back and do the other three. So that's where it gets a little tricky sometimes. Usually they give you the words no matter what, because that's the hardest part to put into place, and then from there you can do the other three. All right, so that's what we're going to do is take one problem and go through all four different representations to make sure you understand what they all look like and how they're set up. And then in class, we'll practice with some more with actual examples and problems that you can tie together. All right, so the next part of your notes is going to tell you the directions, which is going to say represent the scenario in four ways. In all four ways. That means by the time we're done, we're going to use this same scenario and show how it's in words, equations, tables, and graphs, all four of those ways. All right, so the first thing we're going to show are the words, because like I said, it is easiest to start with those, and typically that's what they give you to start with. So in words, here is our scenario. Tammy wants to buy a CD case and some CDs. The CD case is $5, and each CD is $10. All right, so that's our scenario in words. So we don't have to come up with any other words. They've already given them to us. From this scenario, though, we're going to get the other representations off of this. So the best and easiest and quickest way to go through this is exactly the order I'm getting ready to show you. Once they've given you the words, the next thing that is the easiest to come to in terms of the representations is the equation. Okay, because every problem that you're going to see here is going to be able to be turned into an equation. All right, so when we write an equation, we have to identify what we have. We're going to use the letters X and Y. The X is going to represent the number of CDs in the problem. We don't know how many CDs she's got right now. Okay, and the Y is going to represent the total cost. So you will have an X and a Y in your equations, because from there we're going to do the table and the graph, and tables and graphs use X and Y's. All right, so in our equation we have to use the letter X to represent the number of CDs and the letter Y to represent the total cost. So from our problem, we know that the total cost, which is Y, is going to equal, okay, and then we have to figure out how the 5 and the 10 falls into place. The CD case is $5, and there's nothing that's going to change that. So that $5 is a guarantee. So she has to buy that $5 CD case first. Okay, and then from that, she's going to add to the cost of that $5 CD case $10 for every CD. Well, the problem is we don't know how many CDs she's buying, so that's where the X comes in. And because they're $10 a piece, that would be written as 10 times X, or 10X. So your equation can say Y equals 5 plus 10X, or you can write it as Y equals 10X plus 5. They both mean the same thing, and they both will give you the same answer. All right, most of you are probably going to prefer the 10X plus 5, though. All right, so now that we've got the equation written, we're going to take that equation, which is modeling that word problem, and we're going to make a table out of it. So this will be representation number 3, right? And in the table, we have to have certain things, right? We have to have values for X. We have to have the rule. So the rule is whatever comes after our equal sign in our equation. So in our case, this is going to be 10X plus 5. we have to have the y column, because that's going to be what helps us get our outputs. Okay, and then over here, if you want to make a fourth column, the fourth one is usually the ordered pair, so that you can make that graph happen in the next one. You don't have to have that fourth column there, right? But if you want to put it there, you can. All right, so for the x and y values, you have to pick the x values. All right, well, you can't have negative CDs, so we know we're not going to pick negative numbers. All right, so let's go with 0, 1, and 2. As long as you have 3 numbers at least in your table's good. It should never have less than 3, though. It can have more, but never less. All right, so if we look at it, if we buy 0 CDs, that would be 10 times 0 plus 5. In other words, she's just buying the CD case. Well, if that's all she's buying, it's going to cost her $5. Okay, well, if she buys 1 CD and the case, 10 times 1 is 10. 10 plus 5, that'd be $15. Right? And if she buys 2 CDs, that's 10 times 2 plus 5. 10 times 2 is 20. 20 plus 5 makes 25. So now when you go to set up your order pairs, you've got the x and the y from the table that makes the order pair happen. And this is going to lead us right into our graph. Right? So now our table's complete from the situation. Right? Then the fourth representation is the graph. Now, ideally, you would want to put the graph on graph paper, right? But in this case, for our purposes, we're just going to sketch a rough draft of the graph and let it be what it is. All right, so because this is not having any negatives, you don't need anything more than the x and the y axis in the first quadrant. Right, so something that looks like this, and you're used to doing these from science. Right, now the bottom is going to represent your number of CDs. You have to label your graphs. Without labels, nobody knows how to read them. Okay, and then the left side is going to be your total cost, which is your y value. Right, and then if you notice, when we were doing our x values, we only went by singles. So we have 0 here in the corner, and then 1 and 2. And if you had more, you could put more on the graph, but we don't have any more dots. And then for the total cost, because it's so big in terms of going up to 25, it's safer and easier and faster to count by 5s on your axis so that you can fit everything in. So once you have your graph set up, now you're ready to plot your points. And when we plot our points, that's going to be our graph representation of this whole problem. Right? So the first order pair is 0, 5. Right? So you go straight up from 0 to the 5 and you put your dot. Okay, then the next one with 1 CD, it costs $15, so you go over to 1 and up to 15. And at 2 CDs, it costs $25, so you go over to 2 and up to 25. Right? Now, the one thing you have to understand is when to connect them and when not to connect them. Right? In this case, right, we do not want to connect. And it's because of the situation. Okay, you can't buy 1.5 CDs. So if you connected these dots, you would be able to tell me how much 1.5 CDs cost, and we can't do that. So we do not connect because you can't buy 1/2 of a CD. Okay, now there are some instances where you can have a half in there and it is allowed, and in that case you would want to connect them. All right, but for this instance in this situation, no connecting. All right, so then the last thing we want to talk about are some words, 2 words actually, that you have seen in science and I know you've dealt with in science, but they also show up in math. So I want to show you how they relate to the math side of things. All right, and those 2 words are the independent variable and dependent variable. So we're going to start with independent variable. Okay, and again, the key piece being right here with the in. That means it goes into the problem. So in math, the independent variable in terms of your graphs is going to be the variable, and remember variables are letters, for the input of a function. Right? And what this means is that whatever this is, it affects the value of the other variable. Okay, and because we are putting it into the problem or in the input spot, the independent variable is always coordinated to the x value It is the letter X, or whatever variable is attached to the rule. That's how your answer is going to be affected, because that value is going to keep changing. Typically it's an X, but when equations don't have an X, it's whoever is attached to the mathematical rule that you have in your equation. Right? Otherwise, it's whatever your label is on your X-axis. Right? Now, the other word that goes along with independent variable, and its complete opposite, is going to be dependent variable. Okay, and your dependent variable is your variable. So once again, it's a letter, not a number. Don't ever give me a number for these situations. A variable for the output of a function. And an easy way to remember this is that it depends on. So it's got its own word in there. Dependent variable depends on the value of the other variable. And because it is coordinated to the output in math and in equations, it would be coordinated to the y value. Okay, and if you remember the list of synonyms we did in the last set of notes, remember dependent, output, and y value are all on the same side together, just like independent, input, and x value are all on the same side together. So if you know your synonyms, it does make this a little easier to deal with. Right? So you'll be given some situations you'll have to identify independent, dependent variable from, and you will also be given equations that you will have to identify independent, dependent variable from. So just taking a quick look at an example of an equation, just because that's going to be the newest form for you. If I have the equation y equals 7x plus 2, it doesn't matter what any of this stands for, but there's an independent variable and a dependent variable sitting in this problem. Your independent variable is always where you put numbers into the problem, and we put numbers into the problem in the spot of the x. That is your independent variable. Just the letter x, not the 7 and not the 2. Okay? And then where things come out of the problem, the output of the problem, the variable is the y. Okay, so notice you are never picking a number when you're doing this. It is always a letter from an equation. So that letter y depends on whatever happens on the other side to come out. All right, so we'll work more with this in class, and we'll give you some more scenarios and see how well you're adjusting to it. But that's the newest terminology and the newest things that we're going to be talking about next.